Hello everyone, myself Hans. Today we are going to solve the problem of vector differentiation. Question is given, find the directional derivatives of xy square plus of yz cube at the point 2 comma minus 1 comma 1 along the tangent to the curve, and the curve is x is equal to at into sin t and y is equal to a cos t and z is equal to at t is equal to pi by 4. This is the important problem from vector differentiation. Let's solve the problem. Given here phi is equal to xy square plus of yz cube, and here the curve is given by x is equal to at into sin t and y is equal to a cos t and z is equal to at, and we have to find the tangent to the curve at z is equal t is equal to pi by 4. And here the first we have to find direction derivatives of xy square plus of yz cube at a point. Here point is given. This is at point 2 comma minus 1 comma 1. First we have to find directional derivatives of xy square plus of yz cube. This is directional derivative. This is given by del phi, and this is del represent del upon del x into I cap plus of del upon del y into z cap plus of del upon del z into k cap, and here the value of phi is given by xy square plus of yz cube. Further we have to proceed. We can also write this is direction derivative equal to here differentiating first del upon del x with respect to x. Here this is xy square. Here x is the function of y and here is not present x, so we have this part is 0, and here y square is taking constant. This gives, and differentiating x with respect to x, this gives 1. This is y square I cap plus of, and del upon del y z cap differentiating the with respect to y. Here both the terms containing y. First we have to differentiate xy square with respect to y. This gives, once again, this gives xy square differentiating with respect to y, taking x as a constant. This is x is taking constant, and y square differentiating with respect to y. This gives 2y, and plus of here z cube is taking constant and y differentiating with respect to y. This gives 1. So we have to write here j cap, and further for k cap del upon del z differentiating with respect to z. Here xy square, here z is not present, so these parts become 0, and here yz cube differentiating with respect to z, taking y as a constant, y is taking constant, and z cube differentiating with respect to z. This gives 3z square into k cap, and further we can arrange. This is directional derivatives. Del phi is equal to here y square I cap plus of, here we have to multiply here. This is 2xy plus of z cube into z cap plus of here 3yz square into k cap, and we have to first find directional derivative at a point 2 comma minus 1 comma 1. So we have to find directional derivative at 2 comma minus 1 comma 1. Here 2 represent x and minus 1 y and 1 is z, and we have to put here in place of x is 2, and in place of y we have to put minus 1, and in place of z we have to put 1. Here we have to put in place of y. Here is minus of 1. Minus of 1 on 1 squaring, this gives 1. So we have to write here I cap plus of here 2. In place of x we have to put 2, and in place of y we have to put minus of 1, and plus in place of z we have to put 1, and 1 cube is 1. So we have to write here this is 1 and this is z cap, and plus of here 3 into, in place of y we have to put minus of 1, and in place of z here is 1, and 1 of square is 1, so we have to write here 1. This is k cap, and further we have to write this is del phi directional derivative at 2 comma minus 1 comma 1 is, here we have to solve, this is I cap, and when solving this is 2 to the 4, 2 to the 4, and this is minus of 4, minus of 4 and plus of 1, this gives minus of 3, this is minus of 3z cap, and here we have to multiply with 3 into minus 1 into 1, this gives minus of 3, minus of 3 cap, 3k cap. This is the directional derivatives at a point 2 comma minus 1 comma 1, and further we have to find along the tangent to the curve, and the curve is given by x is equal to at into sin t, and y is equal to a cos t, and z is equal to at t is equal to pi by 4. First part we have to solve. Let this is the equation 1, and further we have to solve for second part. We know that r vector is equal to xi cap plus of yj cap plus of zk cap, and the curve is given by x is equal to at into sin t, and y is equal to a cos t, and z is equal to at. So we have to put here, this gives r vector is equal to, in place of x we have to put at into sin t I cap, plus of, in place of y we have to put a cos t into z cap, plus of, in place of z we have to put at into k cap, and further we have to find tangent vector. Tangent vector is given by tangent vector, this is given by dr upon dt. Differentiating given r vector with respect to t, this gives, from here we have to use here at into sin t. This is the two function, here we have to use first second formula of differentiation, taking sin t as the first function and at is the second function. So we have to write here sin t is the first function, and differentiating the second function at with respect to t, this gives a plus of again first function, this is at, and differentiating sin t with respect to t, this gives cos t, and this is I cap, plus of here a is taking constant, and cos t differentiating with respect to t, this gives minus of sin t. So we have to write here minus of a sin t, and plus of here at differentiating with respect to t, this gives a k cap, and further we have to find, once again we can also write this is dr upon dt is equal to here, this is a sin t plus of at into cos t, this is I cap, minus of a sin t and plus of a k cap, and we have to find tangent vector at, tangent vector at t is equal to pi by 4. So we have to write here dr upon dt. This is given by t is equal to pi by 4. Here we have to put in place of t. This is pi by 4. This gives a, and here is sine pi by 4. In place of t we have to put pi by 4 plus of a into t. Here we can also put pi by 4. So we have to write here pi upon 4, and here cos. In cos t we have to again put in place of t. This is pi by 4, and this is I cap minus of a, and here we can also put sine pi by 4 and plus of a k cap. And further, once again, further we have to write here the first directional derivative here. This is del phi at 2 comma of minus 1 comma of 1 is equal to is given by here I cap minus of 3j cap minus of 3k cap minus of 3k cap. We have to let here this is equation 1. So we have to write here to further solve the given problem. And here we can also solve. This is given by a, and the value of sine 45 is, we know that sine 45 this gives pi means 180 upon 4. This gives 4 4 is 16 and 4 5 is 20. Sine 45, the sine value of sine 45 is 1 upon root 2. So we have to write here a upon root 2 plus of a into pi upon 4, and here we can also know that cos 45, the value of cos 45 is also 1 upon root 2. So we have to write here 4 root 2, and this is I cap, and minus of here we have to put here sine 45, the value is 1 upon root 2. So we have to write here a upon root 2 plus of a into k cap. And further we can solve here taking LCM. This is 4 root 2, and here 4a plus of a pi, and this is I cap, and minus of a upon root 2. This is j cap, this is j cap, and plus of a into k cap. This is a tangent vector at t is equal to pi by 4. And we can also take a common from here. This is given by a is taking common, and this is given by 4a. 4 here 4 a is taking common, then remaining is 4 plus of pi, 4 plus of pi upon 4 root 2, and this is given by I cap, and here is minus of a is taking common. This is given by minus of 1 upon root 2. This is j cap, and here is plus of k cap. This is a tangent vector at t is equal to pi by 4. And further we have to find the unit tangent vector. This is given by, once again, unit tangent vector is given by, this is given by the a into 4 plus of pi upon 4 root 2 I cap, and minus of 1 upon root 2 j cap, and plus of k cap. Upon we have to find unit tangent vector, and we know that unit tangent vector is given by n vector upon mod of n vector, and mod of n vector is represented by the vector n in the square root we have to squaring. So we have to write here 4 plus of pi upon 4 root 2 ka whole square, and here we can also write here plus of, we can also write here minus 1 by root 2 ka whole square. This is given by minus 1 by root 2 ka whole square plus of 1 ka square. And further we have to solve. We can find the unit tangent vector. On solving, this is given by a into 4 plus of pi upon 4 root 2, and this is I cap minus of 1 upon root 2 into j cap and plus of k cap. We have to solve in the square root. This gives 4 plus of pi ka whole square. We have to open. This gives 16 plus of pi square and plus of 2ab. This gives 4 to the 8 pi upon here is 1 squaring of 4 under root 2. This gives 32. 4 4 is 16 and root 2 into root 2 is 2. This gives 32 plus of 1 upon 2, and here is plus of 1. And further we have to find required directional derivatives. Once again, this is dr upon dt. This is tangent vector at t is equal to pi by 4. We have to rough here, and further we have to find required directional derivatives. Required directional derivative is, we have to use equation 1. This is given by I cap minus of 3j cap and minus of 3k cap. We have to dot product with the unit tangent vector at t is equal to pi by 4. So we have to write here, this is given by, once again we have to use the taking 1 second. This is a here. We can also once again on squaring here. Here a is, we have to take in common. When we have to find unit tangent vector, here is a is already present, so we have to taking the coefficient of squaring. We can also taking here a is outside and a to a is cancelled out, and here a to a is removed. So we have to write here, this is 4, once again 4 plus of pi upon 4 root 2. Once again we have to write here, this is I cap and minus of 1 upon root 2. This is j cap plus of k cap upon, here we have to write, this is given by under root of here. We can also solve the given part with, once again this is written as 16 plus of pi square plus of 8 pi upon 32 and plus of 1 by 2 and plus of 1. We have to solve this part. We get the required directional derivatives. On solving, we have to do with the cross dot product. This gives, on multiplying I cap with I, this gives 4 plus of pi upon 4 root 2, and when we have to multiply j cap with the j cap, this gives minus 3j to minus 3 minus I 1 upon root 2j, multiplying with this gives plus of, once again plus of 3 upon root 2, and we can also multiply minus of 3 k cap with the k cap. This gives minus of 3, and upon, here is upon under root of, we can also solve further here. This gives, taking LCM, this is 32, we have to take LCM is 32 in the roots, and here is 16 plus of pi square plus of 8 pi, and here divided 2 with 32, this gives 16, this is plus of 16, and here is 1, so we have to write here 32, and further we have to solve. We can also take the LCM in the numerator. This gives, first we have to take here LCM once again, and we can write here, this is the required solution. We can also solve further to simplify the given expression, like we take LCM here once again. This is given by 4 root 2 is taking LCM. This is 4 plus of pi, and here is root 2, here is 4 is not present, so we have to write here plus of 12, 4 is 12, and here is 4 root 2 is not present, so we have to write here minus of 12 into root 2 upon, here is under root of 16 plus 16 is 32, 32 plus 32, this is 64 plus of 8 pi plus of pi square upon, this is 32. This is the required solution of the given problem. Important problem from the vector differentiation. Thank you class, and thank you for watching.